Okay, I want to introduce Jeremy to you. Jeremy has a degree in mathematics from the University of Adelaide, and he's come over to Western Australia, where he's been working for Department of Agriculture and most recently in the CSIRO's Data61 initiative. So Jeremy works on all things around remote sensing, including work associated with the Land Monitor program, looking at saline land and also rangeland monitoring. So recently he's been working on a review document with WABC, which is the basis of this presentation. And with that, I'd like to pass over to Jeremy, and I hope you enjoy the talk.
Good afternoon. Good afternoon, all people, and welcome wherever you are. And thanks, Matt, for the introduction. This talk is actually a review of a review. So I do on monitoring native vegetation using remote sensing. The report commissioned by WABC was published last year, and I do suggest that you download the report and read it. There's a lot more material in there than I'll be able to cover in this 35 or 40 minutes. And you can also use it to fact check what I actually say during the next session today. There's some quite detailed images. I hope you're able to see them as we go through the talk. So I suggest that you configure your system to like minimize my head and maximize your screen view. And while you do that, I just want to thank my principal author of the report, Don McFarlane. And there's thanks to many, many people in WA state agencies who contributed their knowledge to the report, to my former colleagues in the CSIRO Data61 group, and to people from NRM agencies in all the other states who gave time and information that you find in some detail in that section of the report. And just to clarify, the focus of the report was really about there was quite explicitly about statewide information with a focus on, but not exclusively on, native vegetation extent and clearing and condition. So it's good to examine and start with what drove WABC to commission the report and why it was actually done. And the bigger context to that is that 90% of Western Australia is effectively vested in the government as Crown land, and it's the government has an obligation to manage it in the public interest long term. And in the context of that, there are multiple agencies concerned with specific aspects relating to native vegetation management, regulation, and particularly development. There's specific legislation and regulations around a lot of those processes. And the report was really commissioned because some of the leading people in those agencies realised that the data that was being used in a lot of those processes was really inadequate to the task, especially on the statewide scale. WA has a lot of native vegetation under various tenures, and there's a lot of specific information at sites, but really there's no commonly used data that covers the whole state that can provide an update on the cumulative effects of developments, human impacts, and other processes that are affecting native vegetation. More pragmatically, information gaps have costs. The costs of delays in the approval process are well known and can be quite huge at times. So any chance to improve on the data that increases the confidence or speed of those government decisions and reporting would be a good thing. And remote sensing is obviously a candidate. Sometimes the push factor becomes shove factor, and there's a report from the Auditor General reviewed the Management of Pastoral Lands Board, which is a mandated role for PLB. And basically this text here is from the summary. The information that they're using is that was judged not good enough to actually carry out the mandated function, and there was a suggestion that the PLB should be making more use of remote sensing technology to carry out its mandated role. There are also what you might call pull factors. My neighbour's got one, I'd like one too. People in state agencies know that there are functioning remote sensing systems operating in some states, particularly Queensland. There's a national system. There's national data sets now. So there are examples of operational programs at various levels, and there are lots of detailed projects at what we call project level, where remote sensing is providing information on vegetation and vegetation change. There's also technologically, there's quite a capacity in WA, a lot of experience. And in recent years, there's been massive advances in the access to relevant data sets, free of cost, and to the pre-processing of that data. So the data provisions from the international agencies in the US and the European Space Agency, the housing for a lot of that data now in Australia is in Geoscience Australia's data queue. The computational advances mean that we can handle large data much more easily, much more efficiently, and quite a lot of those advances with respect to vegetation information have been made and demonstrated here in WA. So in case you have to leave early, I thought I'd go straight to the end, and the major conclusion of the report is that the WA technical experience and capacity in relevant remote sensing is strong. And personally, I think that's actually an understatement. You know, the capacity of the group, my former group at CSIRO, is recognised nationally and internationally as really leading, both in technology and in making that technology operationally applicable and work to policy questions. And they've also worked for many years with state agencies. So the technology risk of adopting remote sensing in the current environment is not very high, but there are some recognised gaps that we came across, that the potential of the current data sets are really not being realised across government, and there's a need to address some of those issues. So that's the background to why it was done and the major conclusion. And the rest of the talk, really, there's a lot of ground to cover, and I will chop around a bit, but for those who came in late, this is a summary of the relevant data and its status that might provide statewide information, remote sensing. Most people will be familiar with all or some of this, but the famous satellite series is Landsat. It's been at 30-metre resolution since the late 80s, which means there's 32 years of archive, twice a month roughly, held and pre-processed in the GA data queue. More recently, the Europeans have come up with an optical satellite series at higher resolution, which sounds a lot better. It started in 2016, so now we've got at least 3 years of data, started with routine. So we're in a position to evaluate it and apply it for monitoring at this point. It's higher, more frequent acquisition. There's more data in a single acquisition because of the higher resolution and other things. That data is also stored and is testable GA. Sort of even newer in the block, in fact, since I retired, there's been significant work done with the Sentinel-1 radar series. It's really the first satellite series that's going to deliver radar information with full coverage and into the future. So it now becomes a practical thing to examine for operational work. And there's been some progress in that also in WA in recent years. The sort of forgotten one is air photography, which has extraordinary resolution, and it's really practical, became collected digitally since about 2007. It's frequently collected over the greater Perth area, but not very frequently collected elsewhere in the state. The data volume is large, but it has some unique properties. And the data volume is kind of relevant because Western Australia is a very big area, and we're implicitly talking about multi-temporal coverage. So all of these things are getting towards around what you might call big data, but with the advances in computing, we have a very big computer. So this is no longer the problem you might think it was. It's good to have a look at these existing statewide data sets that really raise the concern in the first place. This is a BIRD map. This is the underlying statewide map of pre-European vegetation types. It was created many years ago and it's been digitized, but it's never been updated, and it's very coarse resolution. In terms of the existing native vegetation, there's a vector data set. There's the pink lines here over a photograph. It's known as the Native Vegetation Extent Dataset. It's updated manually and irregularly by DPIRD. So these datasets are essentially static, and they're not really amenable to answering a lot of the questions or even providing the context for a lot of the pressing management questions that agencies are faced with. And I think it's quite interesting because in my career, a lot of the traditional mapping and vegetation people are kind of skeptical about remote sensing. But in my working life, the remote sensing data has actually developed enormously in what the kind of products that it can deliver and is delivering through Land Monitor and other programs. So now we see regularly image mosaics statewide. We're seeing woody vegetation extent and change products statewide. We've got cover trends products over large regions of the state, and these are spatially detailed and updated. And since I retired from that group, there's been even further improvements, some of which I'm able to show you quickly later on. I just want to take another look at this native vegetation data set because it leads into a comment that surprised us. The map at right, I don't know if you can see the detail, but the colours basically represent in the most recent aerial photography capture over the wheat belt. And basically, this is at 2017. If it's a yellowy colour, it's at least 5 years old. If it's a greeny bluey colour, it's at least 10 years old. So that tells you straight away that there is not an updated or a consistent or a single temporal coverage that's possible to update a vector map. There are other problems with manual interpretation, but really this sort of technology is unsuitable to provide the monitoring information that some of these agencies are looking for. A further comment that really is, people were very happy to use this data set because they were used to it, but also because it was in vector format. And there was one of the barriers to the use of image products is that they're in raster or grid format. And really that's not a technical barrier anymore. And in fact, I think as spatial data sets get larger and more detailed, vector format really is not a suitable format for the data at all. So there really needs to be a need for agencies to get to grips with a raster GIS capability if they haven't already. Okay, and now I want to show some of the products that are generated from remote sensing, and in case the resolution is not great for you, I'll try to talk to them a little. But this is this area, some of you will know it, it's known as the Great Western Woodlands. It's a very large area of native vegetation covering the goldfields. And you know, on the vegetation map of Australia, it appears as a static blob of with some beard lines over it. This map is created from Landsat, from time series over 11 years, 12 dates, and the colours actually represent different disturbances or changes in the cover of vegetation. Fire is a major factor, but it's not the only thing going on. There are other more subtle declines in some of these red colours over here. So this image gives you an indication of where and when vegetation has changed, what's happened since the drought or since the big fire of so-and-so or since we changed the management. And for people doing botanical surveys, if they're looking for unburnt vegetation or some kind of plant succession information, or even if they're doing any kind of survey information, this is a very important, valuable backdrop to what they're actually looking at in terms of the processes that have affected that vegetation. So this is like a colour key that the vegetation is actually dynamic and changing over time. And it gets even better because we can, because it's come from time series and numerical time series, we can interrogate that time series and plot it as numerical values for any area we choose. And what you're looking at here is a similar kind of image. This area happens to be a detail near Coolgardie, the periods 2000 to 2014. And there are two different colours because there are two fires that affected that area at different dates. And I don't know if you can see, but there's a little polygon there which I've used to plot out this line here. And there's another one here in an unburnt area. So the unburnt area represents, if you like, a stable benchmark against which the fire impact can be assessed. They're very similar. We know the fire occurred in 2003, if you can read the legend. We know that after 10 years, it's barely recovered in cover. The other fire was later. It was not so severe, but similarly, it is barely recovered in those run of years. There's an important concept here that there's a benchmark which I've chosen as a stable site, but that benchmark could also be any known reference site for ecological comparison as far as change or disturbance is concerned. So this technology is real. It's the data sets that do this exist for the whole state, and some of these products are generated routinely in Land Monitor. As to woody vegetation extent and clearing, that's been operational also for a long time, and here's in incredible detail. I just wanted to point out for those who are not familiar with this, that this is a different process. In order to estimate areas and pick up change areas, the image data is actually goes through some sort of classification and then some sort of change detection algorithm. So at this point, the image data has been rendered into a thematic map, and the difference over time can be shown as clearing. I like this example, it's quite old, because it shows that we've been able to pick up, if you like, the narrowing or the thinning of this roadside vegetation corridor over that particular period. So that's an example of 2 dates, and a cleared area and a remaining vegetation area. Of course, we can calculate the areas of those. On a slightly larger scale, here's a large chunk of the south coast, and most of you will be familiar with the shape of the Stirling Ranges, the Prongerups, Albany, Denmark is here, Walpole is here, Lake Muir. So here's the time series. I'm going to show you a slideshow, so just bear with me. This area is quite a large portion, but of a map sheet known as SI50, which is starts in Fremantle and goes as far as Ravensthorpe. And it's kind of a time machine. So in this image, we're looking 43 years ago. The green colour is woody vegetation. The red colour was cleared during this 3-year period. The green is some kind of recovery of vegetation or regrowth. And the blue is former regrowth from the series which has been stored and accumulated. So we can actually see what's happened to land vegetation, woody vegetation extent, using the time series. We can go the next 5 years, 80 to 85, clearing was very active in the region. You can see, and there's also some fires removing vegetation in the Stirlings. As we go through the 80s, the clearing is much less. And by the end of the 80s, the clearing for agriculture is almost stopped. I believe the legislation came in about then, so that shows policy impact. If we get into the early 90s, we're seeing in blue sort of accumulating forest recovery, some recovery from fire. And in the mid-90s, you start to see the plantation roll out of blue gum plantations. So light green is new plantations in that period. And as we go through, we can see how the blue gum cover has altered that landscape. And we get into the mid-2000s and some of the blue gums are harvested. If it's yellow, it's not replanted. And the red is the current reharvest. So this is now in annual time steps. And it's really a demonstration, I've stopped there by the way, of the capacity to monitor change in extent of woody vegetation. Of course, people who are alert will realise most of those blue gums is not strictly native vegetation. And some of the impacts, of course, are not clearing, but they're fire. So really you need some other knowledge or other information to attribute these processes. But the fundamental monitoring information is fully available at 25 metres for this area, and that's part of a larger area. In fact, it's available in this form. It's up to date for the entire country. This is just shows that if you have that map sheet, you can turn that image into statistics. There's nearly 5 million hectares of woody vegetation in that map sheet, and it really doesn't change much over time. But if you want to know where those changes are, you need to go back to this spatial product and use your knowledge and other data to work out if those processes are significant. A sort of more detailed example from the wheat belt is really addressed at this question of clearing versus the sort of nibbling decline of vegetation. There's a lot of small areas impacted over this long period. And under the clearing law, illegal clearing, well, the clearing that needs to be registered, it has to be an area greater than 5 hectares. So none of these areas would pick up. So there are a lot of processes effectively removing vegetation, which are not qualify as legal clearing. DWA has a very effective surveillance system to track illegal clearing at the present date using remote sensing. But a long-term time series like this can provide insights into the cumulative effects of these processes. And if you want to it provides the opportunity really to examine and attribute those to different causes. A slight change of, so there's some examples of remote sensing products which are highly relevant to the background questions and really are extendable over the areas where clearing is an issue and also rangeland areas in terms of the cover monitoring. I need to say something about conditioning because that was really a very big ask. If you're going to monitor something, you need to have a consistent, repeatable measurement as an indicator. You know, when we want to monitor our health, we don't measure our health, we measure our blood pressure. So the actual concept of vegetation condition is complex. It's actually ill-defined or multiply defined. And there's, you know, if you read the papers, that's a problem even for vegetation condition assessment at a site. Biodiversity type condition or condition involves aspects of composition, structure and function. Again, none of those things is defined strictly in terms of a measurable quantity, but we know what they mean. And I would say that remote sensing has a really good opportunity to provide consistent indicators towards structure and function. Obviously, in cleared landscapes, remote sensing, the kinds of images you've just seen, can inform whatever metrics you have about fragmentation or connectedness of vegetation. And the cover has a lot to do with condition. Here's the example from the rangelands. Generally, we might assume that cover increase in natural vegetation is a good thing, but if it's invasive natural species, that might depend on whether you're interested in soil stability or the original biodiversity condition. If it's invaded by exotic weeds, we might think it's bad. But in either case, the key monitoring information is available for remote sensing. You need some additional information to really attach a value to condition. There has been some significant work by CSIRO in Alice Springs where, you know, condition is actually defined in terms of the temporal responses of cover. In fact, its ability to recover after rain. And the reference state can also be defined for remote sensing so that you can track areas compared to the chosen benchmarks, as we saw before with that fire. So really, the remote sensing data sets we have now provide the opportunity to track and compare a relevant indicator so that we can look at what happened to cover responses in response to rainfall or drought or fire. And we can compare those with benchmarks, which can either be chosen from known sites, reference sites, or from the land systems as a whole to really rate those things as good or bad a priori from remote sensing and then tactically label them if that is justified. So I really think condition is a hard ask in itself, but it's no doubt we can get relevant indicators of vegetation change and leave the challenge to the ecologists to turn those into targeted summaries of condition. And before I leave the good pictures, structure is mentioned. Structure at the landscape scale. This is actually an image or a data set derived from digital air photography. It's a 20 centimetre resolution. And what the colours here represent, it's a semi-cleared area near Mandurah. And what the colours here represent is the height of the vegetation or the height of objects above the ground. So they have a metric height. And from this data, the ecologists who are working at this scale had the opportunity to find detailed structural metrics about height and vegetation, which might affect, say, the roosting habitats of cockatoos or whatever. The point is that this is from a program called Urban Monitor. It covers about 10,000 square hectares, 10,000 square kilometres. Is that right? Yep. Of the Greater Perth urban area. And because this photography is acquired repeatedly, the data set's now repeatable. You can actually monitor land cover and land height at a scale. So there's a great opportunity to get quantitative metrics relating to structure out of data sets of this sort. So I've been through the examples. I just the report has quite an interesting section on comparison of state practices. I don't have time to go through it now, but there's some interesting comments. You know, the South Australians just said, look, no one has a working definition of condition. We're not putting any effort into it till there's a convergence of idea about that. Victorians aren't interested in clearing because they think it's all over, woody vegetation clearing. Queensland is the state which has, you know, a very well-resourced vegetation type mapping and also a long-established remote sensing program. But as you see, most of the other states are really in a similar state as it comes to vegetation mapping, and not much of a state in terms of remote sensing. Again, Queensland has a well-known program, SLATS. It's run out of its Department of Science, etc. It's been running for decades and it's very well resourced. The mapping program is also there. They have big staff. It's basically set up because there are particular Vegetation Act requires accurate vegetation type and updates of how much is still there. I mean, I guess its strength in long-term operation is that it is established in the main government regulatory agency. I mean, in terms of technical, it's got a few limitations and it's quite expensive to run. It still retains a higher level of human interpretation in its basic clearing product. And so I'm going to move straight on to the national program, which there's quite a good story behind this. When the Howard government signed the Kyoto Protocol in 1998, Australia had argued for a special clause to include land-based emissions from forestry. The Europeans hated it and they argued against it and they eventually gave in. But that meant that Australia had really set up that they had to produce something that had never been done before and present the results and the whole methodology to a really kind of critical review by the IPCC. The Australian Greenhouse Office was set up in part to manage that. They looked around and they chose, for the essential remote sensing approach, they chose the approach implemented by CSIRO WA in the Land Monitor project, which was quite new at the time. So they contracted my former group to design and implement workflows for this national program at a scale that had never been done before. And that kept us very busy for a number of years, and the group still conducts the updates and the continuous improvement. So what that program generates nationally is woody vegetation. It's evolved to generate sparse woody maps. This is initially from Landsat. And of course, a whole time series of clearing and revegetation, and now transitions from woody to sparse and so on. Once it moved to this sparse woody extension, we're able to really link those products to WA Land Monitor, and they're now identical. From Landsat, it was resampled to be a raster at 25 metres. But really in the last 12 months, Sentinel data has become a reality. The CSIRO group here in WA has evaluated and incorporated a workflow and demonstrated a workflow. And basically the Greenhouse Office has commissioned that group to incorporate the higher resolution data and essentially reset the whole time series to a 10-metre resolution for the country. So that brings me in shorthand to Western Australia's Land Monitor program, which some of you will know very well. It's basically an unusual, very efficient collaborative arrangement. 7 state agencies put in a small amount of money. CSIRO Data61 group processes the data, and it provides the state with annual updates of image data, vegetation products with complete state coverage. So now image mosaics, Landsat and Sentinel-2, the same classification products we've just talked about. And new to me, I just found out in researching this talk, so it's not in the report, they're now providing radar composites, like 12 a year, so they're monthly radar composites from Sentinel-1. State coverage, complete state coverage, they've done that from 2019, and in the process of doing it 2020. And this data provides an opportunity to look at vegetation structure, and I mean, the Department of Fire and Emergency Services is quite excited to evaluate this data because it's looking at the lasting impacts of previous fires, the potential indicators of fuel load, variability in different forest types. And DBCA is also actively looking at that data. And over on the right, you've just got a picture of some wheat belt in Sentinel-1. And this is the product which maps, now in green, it's a single date. Now in green, we have the so-called woody vegetation, which is a nominal 20% or more. And in orange, it's the sparse vegetation. So we have an improved capacity and slightly more complex data. So well, there's a very large section in the report, and I refer you to it, about the state government users of the data. There are some outstanding examples of state agencies already using remote sensing data. One is WER in its clearing surveillance monitoring, using mainly Sentinel-2. That's operational and tailored to the demands of the particular act. DFS, we just mentioned, they're already using land monitor products extensively to look at vegetation disturbances and fire impacts. And now they're interested in the new radar data. The DBCA group, they do an extraordinary range of things. And in my opinion, they're the best conservation-directed remote sensing group in the country. They're using land monitor data, but they also have the capacity to implement their own workflows and download similar data according to their conservation or science problem. And they're delivering to multiple projects. DPIRD, delivering to the Department of Lands, the Auditor General's report. They've been off and on about remote sensing, but at the present they're on. And there's some work coming out now in response to the Auditor General's comments and the use of remote sensing. But I guess the downside is, even though these data and products have been out there and the collaborative arrangement is in place, they're distributed to at least the 7 agencies, the data is often underused. Partly some people prefer to stick with traditional data sets or start again. And there's really a lack of awareness of the data across many parts of some of the relevant government agencies. So I've nearly finished. So in the discussion, I've taken this straight from the report. I think I've tried to demonstrate in this talk the suitability and the existing products which demonstrate that for remote sensing monitoring general vegetation in WA. It's really the only feasible approach. At the moment, you know, having an effective remote sensing group, I think you can probably work out, has some high-level technical requirements. But the technical capacity by world standards in WA is very high. The existing data products are relevant, but underused. And I would say awareness of the technical strength in WA at management levels in some of the NRM agencies is probably not as high as it should be. I guess the risky comment here is that the capacity is fragile. It really depends on a few key individuals. And the CSIRO group, as you know, CSIRO groups can be redeployed and some of them even retire. But the fact that it's the only feasible approach and there's powerful demonstrations that it's operational really makes decision easy. If you've only got one choice, it simplifies, sort of focuses the mind. So really the final recommendation is that the state, in its interest of meeting these information requirements, should strengthen what we have, which is strengthen the capacity and establish and support a coordinated technical data processing group, which is directed to provide policy information. It needs to include or have strong links to R&D capacity. And really the Land Monitor Consortium and the DBCA group's activities provide excellent models to build on for that. Where we got a bit confused was in the state, really the mechanism in the state apparatus for staffing and establishing and maintaining it. I mean, monitoring is a long-term commitment, really. So we sort of kicked that upstairs, and we think the NRM agency CEOs or the senior officers group really should be charged to find a way to implement and sustain that in a better way. Internally, the second major recommendation is that there are plenty of relevant products out there. In areas we recognise, and we were told that there's in many places they're underused. So there needs to be some build up of in-agency capability and use, which, you know, as a minimum, people need to understand what a raster GIS can do and have access to it somehow. In terms of the future, the data sets are large. It's really not practical to run around and redeliver updates to everybody on a CD anymore. As you know, WA has the Pawsey Centre. It's quite conceivable, and it would be a good medium-term aim to have these large data sets on the Pawsey Centre, to have users interact with this technical group, and so that they can actually access the data, get the products they need through online tools, rather than trying to recreate the value-adding processes in the traditional GIS way. There are other recommendations, but I won't put them here but we can discuss them, or you can read about them. And that's the end. We're back down to earth. Thank you.
Okay, well, with that, we'll say thank you very much for your time and going through that with us. And thanks for everyone who came along. We had 85 people at one point, so we hope to catch you all again in the next couple of weeks with our next seminar.